So in this video, we will start our discussion on the smart grid architecture. Let us see how the smart grid architecture will look like. So you see, the smart grid architecture is the layered architecture where we will see various layers built on top of each other. We will see them what is the role of each and individual layer. So we'll see first layer is the component layer. So what does component layer means? So the physical devices which you will see in the substation or in the field or in the other parts of the power system network are part of the component layer. So here the devices will include the generation devices, transmission, distribution devices, distributed energy resources, or the devices which are there in the customer premises. So generation, transmission, distribution, DER and customer premises, these domains will be the part of the component layer. So there are various zones in which you will see the interaction of these components, starting from process, which are within the device level activities, then the field where the devices are connected, then the substations, operations, and the enterprise, that is the company level activities, and then finally the market level activities. Now the component layer which we will see here doesn't mean the physical component, but it is the virtualized component of the physical device. So for example, when we access the computer, we use the physical mouse, but for computer the physical mouse is having interaction through a device driver. So device driver is the virtualized part of the physical component. Similarly, in case of the component layer, whatever the devices we will see at this layer in the smart grid architecture, these devices will be nothing but the virtualized form of those components which we will see in the substation or in the field. Say for example, if we see relay is the physical device which will be connected at the substation, but the virtualized components of various activities which we will do in the relay will be part of the component layer. So these layer will be responsible to acquire the data from physical device at the field, and the processed data, the data which these layers have acquired, will be shared with the other layers. So what are those other layers? So second one is the communication layer. So in case of communication layer, what will happen? The layer will contain various communication protocols. The data which has been acquired by the component layer will be packed with the help of various communication protocols and will be sent to other layers. So communication layer is very important because without having communication layer, the data will not be able to travel from the data acquisition devices to the other layers. So component layer will send data through communication layer to the information layer. Now the third layer, which is the information layer, is the layer which basically converts the data into a standard data formats. So for example, the devices which are interacting with each other doesn't have a standard data format. The data from one device cannot be shared with the other device. So for example, if we have the relay here which is interacting with say circuit breaker somewhere, and both are having different data formats, the relay will not be able to directly interact with the substation circuit breaker because the data formats are different. So the role of information layer is to share the relay data in a standard format back to the circuit breaker so that the breaker can operate. So the data model at the information layer will standardize the data communication among various devices. Now, when you get the data standardized at the information layer, the data is further shared with the functional layer. What is the role of functional layer? Functional layer is that layer where we execute the various power system applications. Say for example, state estimation, contingency analysis, or maybe the other applications like outage management system or metadata management system, or the other applications which are required for the functional aspect of the power system network. Those applications will lie in the functional layer area. So those applications will receive data from the information layer because information layer is considered to be the front ender of the functional layer, where the data standardization, data sanitation and all those activities happen. But then the functional layer will execute the data for better visualization or maybe controlling of any power system activity. So after the functional layer, the next is business layer, where the data processed at the functional layer will be further consolidated and enterprise level view will be generated. Because say for example, at the substation level or maybe at the control center level, the requirement of the software application is the power system monitoring and control. So that falls under the operational domain of the power system network. So day-to-day activities like monitoring the line flow, seeing the fault of a system, or maybe analyzing the contingency activities, all those things are falling under the functional layer. But those who are in a management role and those who are running the utility business, they will not be interested in the functional aspect of the power system network. They want the business information to be filtered from the functional role to be displayed at the enterprise level. Say for example, the utility management would be interested to know how many faults are occurring in the system every month or maybe every year, how the revenue is being realized, whether we have AT&C losses more than the threshold or not. So all those consolidated views are required to be visualized at this particular layer. That's why it is called a business layer, because it directly hits the business aspect of the enterprise. So these are the 5 functional layers where the data travels starting from component layer to the business layer. So the component layer is the layer where you continuously fetch the data from the field devices, then you allow the data to travel through communication layer to the information layer, where the data standardization and the data modeling happens. Then functional layer will have the data processed for any functional aspect of the system, say visualization and monitoring and control of the power system network. And then the business layer will take care of the business side of the power system network. Now let's see the smart grid architecture model as defined by NIST. So you will see this model given in NIST framework. This includes the distributed energy resources also. So first when you will see these boxes, you will come to know that these are the boxes which are nothing but the domains which we discussed in the previous lectures. Say market, operations, service providers, then customer, transmission and distribution, and the generation. So all these 7 domains which we defined in smart grid are part of the smart grid architecture model. Now the first layer which you visualize is the component layer. So what are the various elements which you will see in this model as part of component layer? You will see thermostat, appliances, customer equipments. So these are the components which are responsible for direct data acquisition from the field. So wherever we see various field devices, we will fetch the data from the devices. Then next is the communication layer. So on top of all the physical devices which are responsible for data acquisition, we will build the communication layer. So these the dotted paths which you will see are part of the communication layer, where you are stabilizing the communication, and this information is collected and the premise network is built and the data is traveling to the information layer where the data modeling happens, and then you run the various applications. That is, application layer means the SCADA, meter data management system, DMS, demand response, or asset management. So every domain has the blend of each and every layer to execute the various activities. So for example, in case of customer domain, we have the component layers where the devices acquire the data from the field. Using communication network, the information is communicated and then the information is shared with the various functional applications. Say if you are acquiring data of the customer, the information can go to the service provider, which will run the aggregator, home building management, billing, or other similar kind of applications based on the data which is being acquired at the field level. Similarly, this information can go to the operations domain, where this information is being processed for demand response application, or maybe the distribution management or meter data management systems. So this information travels to various domains based on the functional requirement. So after we get the information processed at various layers, finally we will see the market view. That is, the information will be shared with the market domain, where we have lot of players like retailer, aggregator, wholesalers, and so on, where the most of the applications are the business applications which are part of the business layer, and here the energy trading happens, and based on that the settlement related information is shared with the generation as well as the operations team using communication network. When you will see this architecture, you will come to know that the domains are interacting with each other through various communication layers, and the information is shared by the various applications for functional or the business related activities to be carried out. So from the first instance, if you see this, the architecture looks very complex, but when you see the domain level details, you will come to know that the information is flowing from various domains for carrying out various activities. So in case of customer, the information is flowing from the household devices or equipments or appliances, and for the transmission and distribution system, the information is flowing from the devices which are there in the field, like field devices or maybe the substation devices, and these informations are collected and shared through the various communication networks to the various functional applications. For the distribution, we have substation local area network, then wide area network, and even the field area networks to aggregate the data and share with the various applications. So here the data is going to real-time operation of SCADA, or maybe the transmission SCADA, or maybe the distribution SCADA, and so on. So information flow is a key of the smart grid architecture model.